In this video, we will be focusing on application questions where we are given equations in vertex form or standard form, or even creating our own equations to model a scenario. So let's start with our first example. The cost, C, in dollars per hour of running a certain steamboat is modeled by the quadratic equation C equals 1.8 times x minus 4 all squared plus 127.7, where x is the speed in tens of kilometers per hour. So we're given the equation here in vertex form, which means we should already know a few things. I know this parabola is opening up because the 1.8 is positive, and I know that the vertex is 4, 127.7. Just a quick little property. We'll see if it comes up in any of the follow-up questions. So A, at what speed should the boat travel to achieve the minimum cost? The minute I see minimum, I am thinking vertex. And the fact that this parabola is opening up, and it's going to look something like this, the vertex is a minimum, so it matches up very nicely. Now, we are asked specifically for the speed, and a coordinate on this equation, on this parabola, is going to be x, c. And x represents the speed in tens of kilometers per hour. So the x coordinate of the vertex that we got from up here is 4. So xv is 4. But if I want to translate it actually into the speed, I have to multiply it by 10 to get that 40 kilometers per hour, because x is the speed in tens of kilometers per hour. Therefore, the boat should travel 40 kilometers per hour. And it didn't ask for the minimum cost, but the minimum cost would be $127.70, that C coordinate or the Y coordinate of the vertex. On a certain day, the cost per hour to run the steamboat was $150. At what speed was the boat traveling? Round to the nearest whole number. So 150 is obviously cost. So I'm going to go into my vertex form equation that was given to me, and I'm going to replace C with 150. And our goal here, nothing related to vertex because I don't see the word max or min, is just to solve for x, which is the speed, which is what we're asked for. Now, because this is in vertex form, this is a perfect time to do isolation. Now, in reality, I can expand and simplify to turn it into standard form and then solve by factoring, but it might actually not be possible to factor that specific equation we get, so isolation might actually be the only method. So I'm going to bring the 127.7 over, and it becomes subtraction. And when we do that subtraction, we get 22.3. Next, we need to get rid of the term attached by multiplication, which is the 1.8. So I'm going to divide it out, opposite operations. And this is probably going to be some run on decimal, so I'm just going to keep it in its decimal form because I don't want to lose accuracy right away. Now, I can't go inside my bracket until I get rid of that exponent, so I'm going to square root both sides, remembering when I square root that fraction, it will be plus or minus the number. So when I square root it, I'm going to get plus or minus, and now I'm going to go into the decimal form. And I get approximately 3.5. And on the other side, the square root and the exponent of 2 cancel out. And now we're just left with bringing that negative 4 over. And when we bring it over, we're going to be adding 4. And here are our two options. The positive 3.5 plus 4, which is 7.5, or the negative 3.5 plus 4, which is 0.5. Now, both of these numbers are positive, so that's great. But for my therefore statement, again, because speed is in tens of kilometers per hour, it will have to get multiplied by 10. So, therefore, the boat may be traveling, because we don't know which one, either 75 kilometers per hour or 5 kilometers per hour for the cost to be 150. So there's our first example. We were given vertex form and we were asked explicitly for the vertex in part A, and then we had a little solving question for part B that forced us into that isolation method. All right. The height of the archway of the Sipapu Natural Bridge in Utah can be modeled by the equation h equals negative 0.04 d squared plus 3.28 d, where h is the height in meters and d is the horizontal distance from the base in meters. How high up is it? All right, so just looking at the bridge picture here, I'm going to draw in an x and y axis, and d is the horizontal distance and h is the height. And here's the little parabola formed by the archway, and they're asking how high up is it, or what's the max height. Same thing, so we're looking for the vertex. And we are given the equation in standard form, although it's not a trinomial. It's a nice standard form with just two terms. There's actually a common factor here. So we have two options to find the vertex. We can factor this and average the zeros to get that axis of symmetry and then sub it in, or we can just complete the square to turn this into vertex form. Let's do some completing the square to practice the skill. So we're going to start off by factoring out the a value from the first two terms, which means I'm dividing both terms by negative 0.04, and that's going to give me positive d squared minus 82d. Now, if you don't feel comfortable because there's no constant at the end, you can always add plus 0 at the end if that makes you feel better. Now we're going to take that negative 82, divide it by 2, and square it, which gives us a negative 41 squared, which is 1,681. So we're going to add and subtract that to our bracket. Now this specific number will ensure we get a perfect square trinomial inside the bracket, but we have to add and subtract the number so that technically we haven't done anything because it's 0. Now this last number, the negative version, is useless, so I'm going to selectively distribute that negative 0.04 to kick it out of the bracket. And watch your sign. So I still have that nice trinomial inside the bracket, and then the two negatives make a positive, and when we multiply we get 67.24. And now I can factor that trinomial either with the crisscross, either by looking here for my shortcut, or square rooting the outside terms, up to you. I know it has to start with d because it's d squared, and it should be negative 41. Because negative 41 times negative 41 is 1681 and does add up to the negative 82. And now I know the vertex is 41, 67.24. And we know d is on the x-axis, h is on the y-axis. So now the question is, how high up is it? Which means we only care about the height. So therefore, the bridge is 67.24 meters high. So just a question asking for the vertex from standard form. Let's try another. The equation h equals negative 0.4 times d minus 5 all squared plus 12 models the first rise and drop of a small roller coaster that occurs right at the start of the ride, where h is the height above the ground in meters and d is the horizontal distance from the platform in meters. From what height did the ride start? All right, so starting height does remind me about initial height. Now, if looking at that doesn't remind you of initial height, we can always do a little sketch to guide us. So we should already know our vertex is 5, 12. And we know the parabola is opening down. So maybe it looks something like this. I'm not really sure. Maybe the y-intercept is at the origin. Maybe we're starting right at ground level, or maybe we're starting a little bit on a platform. So here's my sketch. Starting height is here. Now I can see, oh, that's my y-intercept. And if we're looking for a y-intercept, that's when that horizontal distance is 0. So I'm just going to replace d with 0. I could also expand and simplify this to get it into standard form and look at the constant, but that does seem like a lot more work. And when we punch this into our calculator, we should get positive 2. So therefore, the ride starts at a height of 2 meters. Determine the maximum height of the roller coaster and where it occurs. Well, this is perfect. We were given vertex form. We know the vertex is 5, 12, and D is in the X position, H is in the Y position. So the maximum height is 12 meters, and it occurs at a horizontal distance of 5 meters from the platform. There we go. The max height of 12 meters occurs 5 meters from the platform, or however you'd like to word that. So that's a very quick question. We were given the vertex form already, so we didn't have to do anything to work for it. All right, let's try another one, a little bit of a fuller question here, and then we'll go into some word problems where we have to create the equations for ourselves. A stone is tossed from a bridge. Its height as a function of time is given by h equals negative 4.9 t squared plus 4.9 t plus 58.8, where t is the time in seconds and h is the height of the stone above the ground in meters. Let's start with a little sketch here. We have time on the x-axis, h on the y-axis. It's standard form, so I know that's my y-intercept. 58.8, and it's opening down, so I have a feeling my parabola looks something like this. Okay, now let's actually read the question. What is the height of the bridge? Well, the stone was thrown off the bridge, so the initial height, or the y-intercept, should be the height of the bridge, which is 58.8 meters high. That y-intercept. All right, what is the maximum height reached by the stone and when does it occur? All right, here we're looking for vertex because we saw the word maximum. So I'm going to complete the square here to get this into vertex form. So first step, from the first two terms, I'm going to divide out that negative 4.9 carefully, so that I have t squared minus 1t, or just minus t. Okay, the constant stays on the outside. It's going to become that k value later on. Now we're going to take negative 1 divided by 2 and square it. Negative 1 divided by 2 is negative 0.5. And when we square that number, we do get positive 0.25. This is the magic number that will make this a perfect square trinomial. So I'm going to add it and subtract it because I don't actually want to change my equation and mess up the scenario. Okay, the negative version, I don't want it. So I'm going to multiply by the negative 4.9. That's trapping it in the bracket so that it could be removed from the bracket. So negative 4.9 times negative 0.25 is positive 1.225. I'm not going to cut decimals because I don't want to lose my accuracy. And now I'm going to factor the trinomial. I know it should be the same bracket squared. T times t is t squared. To get 0.25, I'm just going to look right here or square root the number, 0.5, and it should be minus because that middle term is negative. And now we get 60.025. Okay, and now our vertex is positive 0.5, comma 60.025. Here's my time, here's my height. And now we can write that in our therefore statement. Therefore, the max height of 60.025 meters, looking back at my word problem there to see what the units are, occurs after 0.5 seconds. And since we have the sketch, we can label this information as well as a reference. All right, next, when does the stone hit the ground? So now we're looking for this point. We're looking for the zeros. Now I can see visually that if I were to extend my parabola back, there is another zero in the negative, so only one of them will make sense. Now if I'm looking for the zeros, I need to set h equal to 0. Technically, I can do it in the standard form, or I can do it in my vertex form. I'm going to do it in my vertex form because if I can't factor that expression, that standard form, I wouldn't be able to solve for my zeros, so going into the vertex form just feels safer. So 0 equals negative 4.9 times t minus 0.5 squared plus 60.025. We need to first isolate for the bracket, which means I'm going to bring the constant to the other side. It's going to turn it negative, which is no problem because in my next step, I'm going to divide out the negative 4.9 to cancel it out. And whatever I do to one side, I do to the other. And we're going to get 12.25. And now we can square root both sides, remembering when we square root, we will get plus or minus a number, and in this case it will be plus or minus 3.5. And when we bring the negative 0.5 over, it will be with addition. So our options for t are positive 3.5 plus 0.5, which is 4, that's logical, and the other negative 3.5 plus 0.5, which is negative 3, which is not logical. So that is inadmissible. It doesn't make sense to have that negative time. So therefore, the stone hit the ground after 4 seconds. And now I can take this, I'm just going to go and label it on my graph. All right, last question. For how many seconds is the stone at least 20 meters above the ground? Round to the nearest tenth. Okay, going to my diagram here, let's say 20 is here. We're being asked how long? Well, clearly from time 0, it's above 20 until whatever that point is, sometime before 4 seconds. So we need to find those values, which means we're going to start off by replacing h with 20. And again, I'm going to go into my vertex form and solve by isolation. So 20 equals negative 4.9 t minus 0.5 squared plus 60.025. And same process here, bringing the 60.025 over. This time we have to subtract it from 20. So negative 40.025. Same as before, divide out the coefficient, and this time I'm not going to get an exact decimal, so I'm just going to keep my fraction, and all I'm going to simplify is that the double negative gives me a positive. And then when I go in to square root both sides, my calculator will deal with that fraction, and I will get a rounded answer here. It's approximately 2.9 when I square root that fraction, but of course positive and negative. And now just like before, bringing the 0.5 over, and it will be with addition. So our times will be either positive 2.9 plus 0.5 or negative 2.9 plus 0.5. So that's 3.4 logical and negative 2.4 not logical, so inadmissible. So this is my only answer, and because the stone already started over 20 meters above the ground, that means it's at least 20 meters above the ground for the first 3.4 seconds. Therefore, the stone is at least 20 meters above the ground for 3.4 seconds. If it had asked when is the stone at 20 meters, then I would just say specifically at 3.4 seconds. Or if I had gotten two positive times here, so like positive 2.4 and positive 3.4, the length of time between those would be 1 second. We'd be subtracting it, but the negative time just didn't make sense. Alright, so now let's look at some examples where we actually have to create equations so that we can solve or find the vertex or whatever it might be. So, imagine two consecutive odd integers. Determine the integers if the sum of their squares is a minimum. Okay, so a few things. I see the word minimum, which is making me think I'm going to be looking for a vertex. I see sum of their squares, which is telling me something about the equation. But it, of course, all starts with let statements. I have two consecutive odd integers. As a reminder, this could mean something like 1, 3, 5, 7. These are consecutive odd. And to get from one odd integer to the next, we're adding 2. So that means if my first integer is x, my next one is x plus 2. And the next one is x plus 4, and so on. So we only have 2 of them. So I'm going to say let x represent first integer, and then let x plus 2 represent second integer. So that's not the next number, but the one after, which would be the next odd. So now let's decipher. Determine the integers if the sum. So that means I'm going to be adding of their squares. So that means raise to the power of 2. So that means the x has to be to the power of 2, and the x plus 2 has to be to the power of 2. So there it is. The sum in the middle of their squares is a minimum. So this is going to equal, I'm just going to say s for sum of squares. So actually I'm going to add another let statement. Let s represent sum of squares. And because I'm looking for the vertex here, I'm not going to replace the sum of squares with a particular number because I'm not solving this equation. I'm just going to manipulate it so I can find that vertex. Now, this equation, the way it is, it's not standard form, it's not factored, it's not vertex form, it's nothing. So I do need to standardize it first, which means I'm going to expand and simplify the x plus 2 squared first, which means I'm going to write the bracket out twice. And now distributive property. X times x is x squared. X times 2 is 2x. 2 times x, and then 2 times 2. Collect my like terms. So I have 2x squares, I have 4x's, and 4 at the end. And because I do want my vertex, I'm just going to complete the square here. I mean, I could also try to solve for the zeros if they exist, and then find that middle term, but I think completing is more efficient and will definitely work. So I'm going to divide out the 2 from both terms, which gives me x squared plus 2x, and then the plus 4 is just chilling. And now I'm going to take this 2 and divide it by 2 and square it. Very repetitive here, but it's an important method. So we're going to take that 1 and we're going to add it and subtract it to the bracket. Here's the beautiful perfect square trinomial. Let's distribute the 2 into the negative 1 to kick it out. And we get 2 times x squared plus 2x plus 1 minus 2 for the 2 times negative 1 plus 4. And now to factor this, x times x is x squared, 1 times 1 is 1. Addition will make the check work to that positive 2, or remember, we can just square root the terms, and plus 2. And my vertex is -1, 2. And now, what do the vertex numbers mean? The -1 is the x, which represents the first number, and the 2 is the sum of the squares. So my first number is -1, which means my second number is x plus 2, so -1 plus 2 is +1. So therefore, the integers are 1 and -1. So it is a bit of a longer question because we had to take that equation we created to standardize it first and then complete the square to get it into that proper form. Let's try another one. So we're still dealing with the same consecutive odd integers, so I'm going to keep the same let statements as before. And now it says determine the integers if the sum of their squares is 202. So the sum of the squares was x squared plus x plus 2 squared, and this time it's not equal to that generic sum of squares, it's equal to the actual number 202. Now, I'm going to replace this portion here of the equation. I can either put it into the standard form we got from above or the vertex form. Now, I can definitely use the standard form and then solve for x by factoring. That's perfectly fine. I can also sub in the vertex form and solve by isolation. I think I'm going to do it both ways just to show you both would work. So here's the vertex form way. And then this would be isolation, or I can take the standard form. And if I were to do the standard form way and solve by factoring, I would have to bring the 202 over and turn it into subtraction and then solve from there. So I'm just going to go through the isolation quicker because we did this so many times already. Bring the 2 over. It's now minus, so that's 200. Divide out the 2 from both sides, so now we have 100. Square root both sides, so now x plus 1 equals plus or minus 10. And bring the -1 over, so that x can equal 10 minus 1, which is 9, or x can equal -10 minus 1, which is -11. And then if x is 9, then x plus 2 would be 9 plus 2, which is 11. And if x is -11, x plus 2 would be -11 plus 2, which is -9. So our integers can either be 9 and 11, or they can be -9 and -11. So that's the isolation method. I did it super quick again because we've gone over isolation so many times in this video. For the other one, I'm going to collect my like terms, get it into that nice standard form. I'm going to do a GCF of 2. And now I need x times x to give me x squared. Just 11 times 9 for 99. I'm going to make the 9 negative. There's 11x, there's -9x. So I'm just solving by factoring. We've done isolation so much that maybe we forgot about this method. So x can be -11 or x can be 9. And then we're back to this right here. If x is -11, the second integer must be -9. If x is 9, the second integer must be 11. Therefore, the numbers are 9 and 11, or -9 and -11. They're both good. All right, last question, and we're just gonna set this one up. We're not gonna do this the whole solving. Two integers have a sum of 8. When one integer, or when one number is doubled and added to the square of the other number, you get a minimum. Determine the integers. The word minimum pops out as vertex. I'm not given anything about consecutive, so I'm looking for two numbers. I'm just going to use x and y. Let x represent first number. Let y represent second number. And now I'm going to reread. Two integers have a sum of 8. My two integers are x and y. If I add them, I get 8. Definitely not quadratic. This is probably going to be a helper equation that helps me create a quadratic equation later on. Next, when one number is doubled, okay, so let's say x, I'm going to double x, and added to the square of the other number, so the other number is y, and the square is y squared, and then we're adding them, you get a minimum. So we get, let's say, s for the sum of these two numbers. So let's say let s represent sum. Okay, this has potential to be quadratic. We just need to replace x and y with something. So I can either isolate for x and y, doesn't matter. I think I'm going to isolate for x so that it's 8 minus y, and now I can replace this x with 8 minus y. And there's my equation. Now I would have to find the vertex, which means I need to get this into standard form first. So 2 times 8 is 16, 2 times negative y is negative 2. There it is. Maybe we rearrange it first. And now we can complete the square if we were to fully solve this. I could have also isolated for y and had 8 minus x, but then when I write my equation, I would have 2x plus 8 minus x squared. So I'd have to do some distributive property with the binomials to get it into standard form, but either way would be perfectly fine. And that's it for this vertex form specific application video.